this is Chapter 5, Fats, Essential Energy Supplying Nutrients. When we begin this discussion, most of us, when we hear the word fat, we already have these preconceived notions in our mind about things that are bad for us. Right? Fat tends to have a very negative connotation. But in general, the term fats are just one type of lipid. And we actually, in common speak, tend to use the term fat actually inappropriately. And we'll talk a little bit about that. Okay. Fats are a type of lipid. Lipids, by definition, right, these are a type of class of molecules. Right, and these lipids are insoluble in water. So lipids cannot mix with water. So easy way to think about this is if you take oil, which is a type of lipid, and mix it with water, right? If you're making salad dressing or something, you'd see that the water and the fat, the water and the oil, separate. Now, there's three main kinds of lipids that we're going to talk about being found in foods. Right? The first are the triglycerides. The triglycerides will be the most common. We'll spend the most time talking about those. Then there are also phospholipids. Phospholipids will be very important in terms of looking at their function. Right? And then finally, the sterols. Now, in addition to listening to this lecture, you should also check out the Fats in Food animation, which has been posted on Blackboard and is also available in Mastering Nutrition. So to begin with, let's take a look at triglycerides. Triglycerides are made of three fatty acid molecules. Notice the prefix tri, meaning three. Right? So there's three fatty acid molecules bound to one glycerol molecule. Right, so if we take a look here, fatty acid molecules, these are long chains of carbons. They are bound together, and they are bound to hydrogens. The reason they're called fatty acids is they have this double bond OOH group, which is an acidic group. This is going to be a typical fatty acid. Now, a triglyceride we often represent looking like this, where these tails represent the fatty acids, and this represents what's called the glycerol backbone. And glycerol is a very particular molecule here. It's a 3-carbon alcohol. Right? When you have this OH group here, that's called an alcohol group. So when we have triglycerides, it's a combination of 3 of these fatty acid molecules with a glycerol. Now, triglycerides can be very different in terms of how they're organized, and they're vary really based upon 3 things. One of the first things has to do with the length of the chain, so the length of the fatty acid. We break these into 3 rough groups where we have short length, medium length, or long, and these numbers here refer to the number of carbons in the chain. So a short fatty acid has 6 or less carbons, whereas a medium fatty acid would have between 6 and 12, and a long fatty acid would have more than 13 carbons. Now, how long a fatty acid is going to have an effect on the method of digestion, how our body digests and then absorbs this, and we'll see that a bit later in the chapter. Another very critical, very important concept when talking about triglycerides is what's called saturation. Saturation refers to how many hydrogen atoms are found around each carbon. So if we take a look over here, right, all of the bonds, all of the available bonds are saturated with hydrogen, right? So they're full of hydrogen. When something is saturated, it's full. Okay. So we'll talk about the different kinds of saturation. And then part of that saturation is going to lead to a shape, right? When we look at these things, even though we look at them as drawings on pictures, remember these are 3-dimensional chemical structures. So the saturation is going to have an effect on the shape of the molecules. So taking a quick look at saturation, when we have something that is a saturated fatty acid, all of these CH2s, right, what we really have is C bonded to a C. This carbon then has 2 hydrogens on it. This one has 2, this one has 2. So if we take a look here, there are no double bonds. So this molecule is saturated with hydrogen. Now, when we talk about unsaturated, unsaturated means not saturated. So think about this as not full. When we have unsaturated, we have some number of double bonds. In the case of monounsaturated fatty acids, there is 1 double bond. Now, when we have this double bond forming, this carbon and this carbon now each only have 1 hydrogen. Right? So they are monounsaturated. Polyunsaturated means that there is more than 1 double bond. So for this example, there are 2 double bonds here. So we have 2 regions where we have this being unsaturated. Right? So every time we add a double bond in, we lose 2 hydrogen. Now this saturation is also going to determine the shape of the triglyceride. So something that is saturated, what we have is a very nice long straight chain that forms. So saturated fatty acids can pack tightly together. Therefore, they're solid at room temperature. Solids have more densely packed molecules. So things that are solid at room temperature are usually high in fatty acids. So think about things like butter, lard, margarine. Okay. These have all of these relatively straight chains packing tightly together. Now, if you compare that to things that are unsaturated fatty acids fatty acids don't stack well together, so that they're liquid at room temperature. Right? These double bonds lead to kinks or bends in the molecule. So instead of having a long chain, we have these bent molecules. So monounsaturated and polyunsaturated fats tend to be oils. Right? And something that is solid at room temperature is called fat. Something that is liquid at room temperature is called an oil. We tend to use the term fat in place of lipid, so we kind of confuse those terms. But here we are talking about oils. So these would be things like our olive oil, peanut oil. Okay. There are some exceptions. So there is something called coconut oil and palm kernel oil, and those are a different exception in the sense of coconut oil and that palm kernel oil are actually going to be liquid at room temperature. Now there's something that you should have heard about, and that is the idea of trans. What is a trans fat? If you go into any grocery store and you look at especially the area where you have your tub margarines, okay, you're going to see things that say trans fat free. If you go to many restaurants now, things will say trans fat free. So what exactly is a trans fat? Trans fats are this kind of sneaky way of taking something that is unsaturated, taking something that is unsaturated and making it solid at room temperature. So something like margarines. Traditional margarines, are what are called hydrogenated. They've had hydrogens added into them, and in doing so, it changes the orientation. So let's just take a look at what is cis versus trans. Now these are chemistry terms. If you've had chemistry terms, you've heard of cis and trans before. When we look over here we have, this is the chain, here is our double bond. This double bond, you can almost imagine things can rotate around this double bond. So in this particular rotation here, we have both of the hydrogens on the same side, and that's what the cis means. Okay. So we have the hydrogens on the same side of the molecule, and what that does, that leads to a big bend in this molecule. It causes a kink in the molecule, which leads to this being liquid at room temperature because the molecules don't stack nicely together. So this is a cis polyunsaturated fat. Now trans, and most things that occur naturally that are polyunsaturated occur with this kind of cis arrangement. However, the process of hydrogenation can force hydrogens in, and in a way can change and make this bond right here rotate. And in doing this rotation, what happens is the hydrogens are now on the opposite, or the trans sides. So these are opposite. What that does is it takes this polyunsaturated fatty acid and it makes it more straight chain. It makes it look more like a saturated fatty acid, so that it can be made into a solid at room temperature. That's one of the things that occurs with things like margarines, solid margarines, which come from a vegetable product. The reason they are solid is because they are usually hydrogenated. So whenever we take a look at something, you may see it listed as a trans fatty acid or partially hydrogenated oil. Okay. Partially hydrogenated oil would be taking an oil, something that is liquid at room temperature, and adding those hydrogens, creating trans fatty acids, and it can make that margarine. Right, so that's something to be aware of, and we will talk about that in later parts of this chapter. Now, one of the reasons it's important to pay attention to that is because overall, saturated fats, right, saturated fats being those that lack double bonds, and trans fats, those that have double bonds in the trans conformation, these are thought to be pretty harmful for health because they tend to lower good cholesterol, right, and raise bad cholesterol. We have different kinds of cholesterol in our blood. We'll talk a little bit about what cholesterol is. And cholesterol in and of itself is not bad. It has to do with how cholesterol is packaged. So we have what are called LDLs, or low-density lipoproteins. And low-density lipoproteins are, quote-unquote, the bad cholesterols. Whereas we have good cholesterol, which are HDLs, or the high-density lipoproteins. And when we have too much saturated or trans fat in our diet, we can see a drop in our good cholesterol and raising of our bad cholesterol. Now, there are some fatty acids. Fat in and of itself is not bad. Let's make that very clear at the very beginning. Right? We need fat to live. Right? And then there are some fats that are essential. When we have something that's essential, essential means we need it, but we can't make it. That means we have to take it in the diet. And there are two fatty acids that we cannot synthesize, and they have to be obtained in the diet. And these are considered essential fatty acids. These are called linoleic and alpha-linoleic acids. These are converted into some very important regulatory compounds in the body called eicosanoids. Those eicosanoids include things like arachidonic acid. And these are complex molecules that function in cell processes, how the cells work. So linoleic acid is also called omega-6 fatty acid. This is found in many vegetables and many nuts. This is the one that's converted to arachidonic acid. This is involved with things like blood clotting, blood pressure. It actually acts as a signaling mechanism within our cells. Right? We can't make this omega-6 fatty acid. We need to be able to take it in. Right? So this is one of the reasons why there are quote-unquote good oils and quote-unquote bad oils, or good fats and bad fats. So nuts, if you remember from looking at one of the videos we saw in one of the previous chapters in Unit 1, there was a video about the Sardinian diet that was high in nuts. Right? And nuts are a very important source of this type of omega-6 fatty acid. The alpha-linoleic acid is also called omega-3 fatty acid. This is found in vegetables, fish, and in fish oils. This type of omega-3 fatty acid is converted to EPA and DHA. And you maybe have heard about EPA and DHA. This is also something that is believed to have, they're important in things like inflammation, blood clotting, and blood pressure, but also in how things like our neurons work and how our brain forms. Right? All these fats are important for that. Now, the next kind of lipid we're going to talk about, we've completed talking about triglycerides, and those specific fatty acids are now called phospholipids. And phospholipids are a very specific kind of lipid. Right? The term phospho, right? This phospho comes from the fact that they have phosphate. Right? They have a phosphate group. They do have a glycerol backbone. Right, and two fatty acids. So if you imagine taking a triglyceride and removing one of the fatty acids and adding a phosphate group, a phosphate-containing group, what you get is this phospholipid. Now, what makes these really unique is the fact that this group here, this phosphate group, is polar. It has charge associated with it. So that allows it to dissolve in water. These fatty acids still don't like water, so they still don't dissolve in water. So what you have here is a very interesting molecule in which part of it is water soluble, part of it isn't. So what you get is you get these molecules associating together, and when you look at the the cell membrane of cells, we see that they are a bilayer of phospholipids. These are manufactured by our bodies. We don't really need to take in phospholipids, though we do take in phospholipids. If they're the cell membranes of things we eat, we do take them in. However, we actually can manufacture these. There's no recommended amount of phospholipids we have to take in. However, we do have to take in a certain amount of phosphate, and we will talk about that later in the semester. The third group of lipids that we're going to talk about are sterols. Right? Some of these sterols you may have heard of before. One big one is cholesterol. Right? These are essential components of cell membranes. Many of our what are called steroid hormones are sterol in nature. These have a very unique structure where we have these carbon rings together, where we get these 3 6-membered rings and a 5-membered ring within various branching chains. Cholesterol is going to be the major sterol found in the body. Cholesterol exists in its own form, and cholesterol is also going to be the precursor for all of our steroid hormones. And steroid hormones would be things like estrogen and testosterone and things of that nature. So once we've looked at this fat, we use the term fat kind of generally to mean lipids that we take in our diet. Why? Right now there is a lot of controversy surrounding fat in the diet because there is an obesity epidemic or problem in the United States and actually worldwide. So many people have tried to move to a low-fat or no-fat type diet, and it doesn't work very well. Right? Fat is an important part of our diet. We use it for a lot of things. Right? First of all, fat is very important in energy. Right? Fat is very energy dense. It contains 9 kilograms per gram. 9 kilocalories per gram. We remember that from one of our first chapters. So most of the energy when we're at rest comes from burning fat. When we are doing exercise, vigorous exercise, our body will quickly use glycogen that's stored in the muscle first. Once that glycogen is depleted, it will then switch over to fat burning. That's why individuals who are trying to burn body fat, trying to lose body fat, are encouraged to do more prolonged exercise to get past using that glycogen and get down into burning their fat stores, right? Because when you have excess body fat, we'll talk about adipose tissue, fat is stored energy. Most of us who have any sort of extra adipose tissue have that extra adipose tissue because at some point in time we've taken in more energy than we've used. Our body doesn't like waste, so it takes that energy and it puts it into a storage form. But fat is important for other things as well. We have fat-soluble vitamins, which we need. Things like vitamin A, vitamin D, vitamin E, and vitamin K are soluble in fat. It means they are not soluble in water. Right? They need to be dissolved in fat, and they need fat for their transport around the body. Right? In addition, fats, lipids in general, are important in many body functions. They are a crucial part of the cell membranes in those phospholipids. Nerve cells. If you've had anatomy at any point, you may remember something called the myelin sheath. The myelin sheath is basically a fatty covering that covers our neurons and allows our neurons, or our nerve cells, to function properly. We also have visceral fat. That is fat that surrounds our organs. And a small amount of visceral fat is important because it acts as shock absorber, and it also acts as a friction reducer between our internal organs so that our organs don't rub up against one another. The final thing is that it provides a physical protection. Right? It acts as a physical protection in terms of if you fall down. Okay? It acts as a shock absorber, a cushion. It also acts as an insulator. Right? Insulation to retain body heat. It helps to lower some of the energy that needs to be put into maintaining body heat. Now, in terms of things that aren't really necessary, fat tastes good. Right? Humans wouldn't eat fat if it didn't taste good. Right? So fat tends to provide flavor and texture to foods. Fried foods are obviously very, very high in fat because they're cooked in oil. However, things like salad dressing and ice cream, fat is what allows these things to taste creamy, to have that kind of feeling. And when we eat fats actually help us feel more satiated. And there's two main reasons for this that are physiological, not psychological. One of the main reasons is that fats are more energy dense than carbohydrates. So if we were to eat something that is higher in fat, it would have more calories. More calories should give us more satiety. Fats also take longer to digest. When we take a look at the digestion in the next section, you're going to see that fats really have a much more complex process because they are not water soluble. They cannot be simply diffused or moved into the blood the way carbohydrates and proteins are. So they do take longer to digest. So now let's move on and look a little bit at the digestion of fats. Here you should check out the animations in Blackboard or in Mastering Nutrition, looking at the animations going over fat digestion and lipid absorption, both really good animations. Now in Chapter 3 we had looked at the structures involved in fat digestion and talked about them a little bit. So we're just going to do an overview here of the digestion of fats. A key thing to remember is that Fats are not as easily digested or absorbed because they cannot dissolve in water. So in terms of in the mouth, very little digestion of fats occurs in the mouth. The main thing that gets digested in the mouth, if you remember from the previous chapter, are carbohydrates. Right? There is a little bit of what's called lingual lipase, right? Which is lipase is an enzyme that break down lipids. Right? Lingual meaning from the tongue. But very, very little, because the mouth, saliva, is mostly a watery environment. So when we eat something that's high in fat, most of that fat travels down into our stomach, undisturbed, unchanged. Within the stomach, there's a tiny bit of digestion that occurs through gastric lipase, but for the most part, fat will just get broken into smaller pieces, smaller chunks. If you imagine drinking half a cup of oil, which no one would ever do, that half cup of oil would travel down into your stomach, and that solid mass of the oil would get broken into smaller and smaller and smaller pieces before it passes into the small intestine. That's the main thing that happens in the stomach, is that it gets some breakdown. Now there is the gastric lipase, which will break down some triglycerides, but for the most part it's just a mixing. Now this gives a nice little overview of what's going on in each of these steps. So I do recommend coming back and taking a look at this diagram. The majority of the digestion of the fats is going to happen in the small intestine, and it's going to utilize bile. Bile, if you remember, is produced by the liver, but stored in the gallbladder. And what bile is, bile acts kind of like a soap in the way that it's able to break fat up. Now, bile does not digest fat. Bile takes fat, takes lipids, and breaks them into smaller and smaller and smaller and smaller pieces, smaller fat droplets. It's called emulsification or dispersion, and it allows then some pancreatic enzymes to get into and break up the triglycerides. And the reason we need to do this is because the enzymes, for the most part, are water soluble, whereas fats are not water soluble. So those two things really can't mix very well unless the fat is broken up into very small pieces. So once we do have the bile breaking the fat into smaller pieces, those pancreatic enzymes can then break the triglycerides down into two fatty acids and what's called a monoglyceride. And the monoglyceride would be the glycerol molecule with just one fatty acid remaining on it. Okay. Now once the fat gets taken into the mucosal cell, those are the lining cells of the small intestine, it's taken in as what's called a micelle. And this happens with our fatty acids, our monoglycerides, our phospholipids, our sterols. Within the intestinal mucosal cell, the fatty acids are reattached to the monoglyceride, and we reform the triglycerides. Now, this might seem like kind of counterintuitive that we break it down just to put it back together, but that has to happen in order for the fats to get into the cell. If that didn't happen, these fats would be far too big to pass through the cell. Now, within the cell, protein is going to be added to the lipids. Protein, for the most part, most proteins are water soluble. So by adding a protein to a lipid, you're actually able to form a transport mechanism. We call these chylomicrons. And what these do, these are lipoproteins. And if you look at the word lipoprotein, we have lipid. So we have lipid and protein. So this is actually a combination of the triglycerides surrounded by phospholipids. Remember, phospholipids are those weird lipids that have that water solubility, and proteins, right? So what this does is basically produces a little transport vehicle that's soluble in water. So let's take a look at it. This would be the protein. Here are the phospholipids. So this lipoprotein really is a way of transporting lots of these cholesterol, triglyceride around in a watery environment. Right? So this is what we talk about when we talk about a lipoprotein. Now these chylomicrons can transport the fats from the small intestine and then travel to the lymphatic system. Right? If you remember the lymphatic system in the small intestine, where we have each of the villi of the small intestine, we have that small lymphatic duct called a lacteal. That lacteal is going to take these up. These can transport through the lymphatic system, and then they get dumped into the bloodstream. Right? Once they're in the bloodstream, because they are in this lipoprotein form, they can move around throughout the bloodstream. Now, this happens primarily with our long-chain fatty acids. Short and medium chain fatty acids are able to be absorbed more quickly because they're shorter, they're smaller. It's easier for them to get into cells, so they don't necessarily need to go through this lipoprotein chylomicron stage. And gets to a cell. The triglycerides that are in it have to be broken down again. This time they're broken down by this lipoprotein lipase. Whenever you have ASE at the end of the word, it's an enzyme. So this is a lipase that breaks down lipoprotein. Right? What it's really breaking down is it's breaking down the triglycerides inside, putting them back into a fatty acid, 2-fatty acid, and monoglyceride form, so they can pass back out and into the cell. Then they get reformed. So we mentioned previously that when you look at lipids, lipids take longer to digest because it's so many processes back and forth of taking the triglyceride, breaking it down, putting it together, breaking it down, putting it together. Okay. Once arriving at a cell, the triglyceride can be used either immediately for energy. If there's an energy demand, it can be used right away. It may be used to make some lipid-containing compounds, and there's many structures within the body, within the cell, that are made with lipids. Right? And anything that's excess, anything that doesn't need to be used for building or for energy right away, is going to get stored. Right? It could be stored in the liver, it can be stored in muscle cells, and if there's much extra, it will eventually be stored in adipose tissue. Right? And adipose tissue is the tissue where we have excess body fat. And then excess body fat really are stored versions of fats that we've consumed in our diet. Now, most people who are concerned with fat are concerned with losing fat, right? Losing body fat. And what that is how much extra storage we have of this energy that we've taken in through fats, right? So what we really need to think about is how much fat should we be taking in, right? The AMDR, the acceptable macronutrient distribution range, is between 20 and 35% of our calories should be from fat. And that's for people with a moderately active lifestyle. Highly athletic people, people who are professional athletes, people who do lots and lots of athletic events can actually reduce their fat intake and take in more carbohydrates. And that's because with high intensity activity, carbohydrates are actually a better fuel for that. Fat is better when things are a little slower. But what's important is also to pay attention to what type of fat is being consumed. So saturated fat, those fats that we talked about that come mainly from animal sources, those fats that have that saturation of the bond, those straight chains, those solid at room temperature fats, no more than 7% of our fat calories, our total calories, should come from saturated fats. And current recommendations are that trans fats should be reduced to the absolute minimum. And that's because trans fats have been shown to possibly be even worse in terms of raising bad and lowering good cholesterol than naturally occurring saturated fats. So if we can focus on having our quote-unquote good fats in our diet from things like monounsaturated and polyunsaturated fats, it's much better overall. Now, if you are planning to reduce the fat in your diet, you have to be able to find the fat in your diet. So some of it is obvious. These are the visible fats. These are the things that you can see on food or added to food. So these would be like taking the skin off of your chicken breast before you grill it. Removes a huge amount of fat. Dressings on salads, right? Opting to either not have dressing on salad or use something that's not high in fat. Some of the worst fast food meals are the salads when you utilize the dressing, because the dressing is sometimes pure fat. Now, there's also hidden fats. These are things that you may not be aware of. They may occur naturally. Right? There are many vegetables, there are many things that do have hidden fats. These are not necessarily bad fats, you just need to be aware of them. So in terms of limiting fats, one of the important things is to reduce the intake of saturated fats, avoid trans fats. And the ways you can do that is by shopping and cooking smarter if you shop and cook. This is more difficult if you do not cook. Right? If you eat out a lot, it's a lot more difficult to limit these. And when you are selecting fats, choosing good fats like omega-3 and omega-6 fatty acids are very helpful. Now, one thing to caution on is the idea of fat replacers. Fat replacers are things that can reduce the fat content. It's still on the market. It's called Olestra, brand name Olean. This was put especially into potato chips. In the late 1990s, early 2000s, it was very popular. And what this did was this took a bag of potato chips, and they tasted pretty much like regular potato chips. They weren't like the baked potato chips now. These were regular fried potato chips, but they were fried in this Olestra. And so this was something that was at first pretty interesting because you could have something that tasted full fat without the fat problems. However, one of the side effects of Olestra and Olean were potential gastrointestinal side effects, ranging from slight discomfort to massive diarrhea, depending on how much of this Olestra or Olean was consumed. Now, this is still available on the market. Very few products have it, though, because it really was not very popular. And the fact that these fat replacers exist does not have any effect on the number of calories per se, just the number of fat. And if you look in the book on table 5.2, there's a very nice comparison table of full fat, reduced fat, and low fat foods that we will have as a discussion later on. Now, fats overall, as I said, fats are not in and of themselves bad. However, there are many chronic diseases that are closely associated with diets in very high saturated fat, especially cardiovascular disease, which the following in depth covers. There is some relationship between dietary fat in cancer, but it's still fairly controversial. And so far, the strongest association for dietary fat and cancer has to do with prostate cancer.